One day I found an interesting video.
Hey, Jackie.
Yes.
Saw an interesting video. Check it out.
Whoa!
This is pendulum movement. Predictable.
Yeah.
Connect to.
Oh, fascinating. So regular.
Right?
The
Yeah.
pendulum's clear,
Yeah.
but with 2 weights, it dances.
Yeah.
Isn't it crazy?
Unpredictable, huh?
It appears irregular, but maybe there is still a pattern.
Is there a pattern? I asked my friend in physics. Oh, double pendulum? You can't predict or solve it, so we don't even learn it? Not predictable.
Really?
Yeah. We're gonna
Wow.
take ourselves and observe to see if there really are no patterns.
My gosh.
What if we connect 3 weights?
3-section stuff. Let's do it.
Let's thoroughly explore why it's unpredictable.
Okay, let's go.
It's done, let's assemble it.
Okay, let's go.
All right, the pendulum weights are now complete.
First, second, third.
Second, third.
Attach the first pendulum.
Sounds good.
Swing it.
Not interesting.
The pendulum.
First stage, let's go.
First stage done. Now the second.
It's an unpredictable and strange trajectory, not the usual pendulum motion.
Amazing. Really irregular. Oh,
Oh, what's happening?
spinning around. What?
Seems aware.
Scary, it wobbles. How will the third stage move?
Right, third stage, go.
Your third stage. Okay, it's done.
Now, third stage.
Third wow.
What we saw earlier was up to the second stage.
Now the third.
What if we connect them?
What movement does it show?
So curious.
Ready.
Oh, wow.
It looks intense, movement amplifying.
Right,
Like this.
Oh, wow.
The end moves.
exactly, go.
Wow.
Let's go 3, 2, 1.
Wow. Wow.
What is this?
See the boost?
Wow. Wow.
Wow. I'm so amazed that with just one pendulum it moves like this. But just adding one more weight makes it do this. Is there really any pattern? It's hard to predict as mechanical movement, but it should have some kind of pattern, a very long one.
Estimate it.
Simulate it.
Yes,
Well, it's not that difficult. I coded it so you can see the path it takes when you tap it. It's wild.
Oh, wow.
Oh, this too. No pattern.
Moving randomly.
what is this?
Wow, angular parts too.
I think it's just wildly bouncing around.
I expected this.
Predictable.
Not at all.
We've invited the experts.
I'm Quado.
I'm Gongjin.
Please start.
Is this difficult?
It's time to reveal it.
This is not a difficult problem.
Oh, not difficult.
Not solvable.
Quite challenging.
Jackie and I thought a lot about why there is no pattern. Wow, it's actually not difficult.
And you broke?
Too old now.
Escape now.
Solvable.
Oh my god.
Yes, sounds good. What is Newtonian mechanics? Knowing speed and direction reveals all, like a simple pendulum. You can predict with Newtonian mechanics, but it gets complicated when doubled.
It's not just one thing moving, something's attached, right?
Interactions become complex. Considering direction in a double pendulum isn't easy. Maybe that's why no one did it. The key isn't Newtonian mechanics, there's an easier way.
Joseph Louis Lagrange.
We just prepared this, right?
Memorize the line. Lagrange shows a different analytical mechanics. This is Lagrangian mechanics. Newtonian focuses on direction, but pendulum motion constantly changes directions. Lagrange thought, why not consider total energy instead? That's how Lagrangian mechanics was developed, simplifying solutions. To use Lagrangian mechanics, we need the Lagrangian.
Wow, Lagrangian appeared.
So, we were always curious, why did Geekable challenge something so difficult today? If we go to the triple pendulum, we have considered this third part. It's not easy. I'd like to solve it here, but I'll refrain today.
Not allowed.
You need to solve it, I'm really curious.
Jackie, get the board.
Bring the board.
This can't be content. Mechanics only require you to remember a couple of things when calculating. Since it's Lagrangian, there's a variable L, and then kinetic energy minus potential energy.
The formula calculated with this becomes Lagrangian. It's simple. With Newtonian mechanics, you keep going. F equals ma. F is... You have to consider changes from this position to that.
For potential energy, know its height and position. For kinetic energy, know its speed. Then plug them in accurately, and it works. Even the pattern isn't that simple. Even on energy,
Pattern's complex.
That's why we're talking about it. Why Geekable?
No curiosity.
Oh, that's right.
the PD here, that's good. Experiment without knowing. Faraday's spirit.
Even seeing the double pendulum pattern, we might not feel it. It changes.
Jackie, okay?
Overheated. I really need something cool to drink.
Lots came in. Let's tidy up. Sit, Guido.
Yes.
How organized.
That's right.
With double pendulum, it's unpredictable. The pattern issue is F equals ma. Lagrangian mechanics solves it clearly. Right.
Check energy, not pattern.
Create a math equation.
There is.
There is.
There is.
Pendulum pattern.
Triple pendulum.
There is.
It's completely confusing to the naked eye, but it's amazing that there's a pattern.
Actually, isn't living in the world like a chaotic world? But if you want to find a pattern here, you can. I was really surprised when I saw it. Even just this part looks like a piece of art.
Oh, really?
You can title it Triple Pendulum Clock. Shows how chaotic life is.
Perfect thumbnail.
Life's chaotic. Right. Unpredictable.
Geekball's interests intrigue me. I really enjoy it.
It's meaningful, so we're here.
Yes, with Gongjin and Guido's help, we learned. The conclusion, a tough problem.
Predictable, but it gets solved. Our curiosity continues. Geek Bar.
Geek bar.
Geek bar.